Okay, now I want to shift and talk about the role of chance in the assessment of association. This represents that bottom part of that pyramid that I showed you in a prior slide. So when we measure an association between a factor and an outcome, we then can calculate some statistical measure around that association. Once we have that statistical measure or value, we then have to ask ourselves whether or not that statistical association is true. And that is generally performed by evaluating or interpreting, oftentimes, the p-value, which is generated from that statistical test, which is driven by our original hypothesis, right? So our original hypothesis is probably that risk factor X does not cause disease Y. We collect the data, we calculate a statistical test, and we generate a p-value, and depending on that value of the p-value, we can either decide to reject our null hypothesis that there is not an association, or we can fail to reject. So we often decide to do that based on our p-value and other values that are generated from our data. More importantly, we look at the confidence interval around our measure of association, because that itself provides us with the variability of the true effect size that the p-value itself doesn't. But what is the p-value? And I'll discuss that in a subsequent slide. But essentially, it's a measure, it's a probability that what we observed in this current study, if it's true, if we were to repeat this study over and over and over again under the same conditions, the probability that if our association really wasn't true, that we would see the same thing again. So that's why our goal is to have a very small p-value, because that means the probability of seeing this again under a true null is very small. And then we also want to talk about type 1 and type 2 error. Type 1 error is an error that's committed or violation when we falsely conclude that there is an association between X and Y when there really isn't one. And then type 2 error is where we fail to identify that there is an association between X and Y. That is, we fail to conclude that there's an association when there truly is one. Now, depending on your study and the implications of your interpretation of that study, the type 1 or the type 2 error might be more or less important than the other. So I want to talk about the p-value and some misuses and misconceptions about it. So the p-value is a probability, as I've said already, so it ranges from 0 to 1, that an effect that we observed is at least as extreme or more extreme to that observed that if it had occurred by chance alone under our null hypothesis. It also provides us with a measure of how incompatible our data are with our specified statistical model. So again, the smaller the p-value, then the more compatible our data are with our specified statistical model. The p-value itself does not measure the size of the effect of the importance of the result, right? That's very important. So for example, a study with a statistically significant finding, such as a p-value of less than 0.01, does not tell us anything about that measure of association. So for example, you give a very small p-value in the case here of 0.01, the effect size itself was very small. It was from 7% to 5%, so a movement of 2%. Probably not scientifically meaningful or clinically meaningful. Also important is that p-values do not measure the probability that the studied hypothesis is true, or the probability that the data were produced by random chance alone. That's very important. The p-value itself does not provide a good measure of the evidence regarding our model or hypothesis, and so in general, scientific conclusions should not be based on the p-value alone. Often case nowadays that we focus in on the level of precision around our association measure, right? So we look at so for example, we'll measure a relative risk, and we'll calculate the confidence interval around that, and that will provide us with the variability, which is much more meaningful than the p-value. But here I want to just highlight some misconceptions about p-values. And very important is that the p-value provides us with how incompatible the data are with our model. It also provides us with the level of evidence against our null.